So now let's go through the optional problems for the digital logic design practice problems. So the first one of these was something called DeMorgans Law. And DeMorgans Law says this here. It says not A or B is the same thing as not A and not B. And so for this problem, we're going to go ahead and prove it by filling in the truth table. So let's take a look at that. So here's A and B. Go through all the possible combinations of those. There are two inputs, so we have 2 to the second, or 4 possible combinations. And let's start out. Let's write down what A or B is. So here's A or B. We're just going to be true whenever A or B is true. So this is our standard OR logic that we had down here from our OR gate. Now let's see what not A or B is. So for not A or B, I'm just going to take this and invert it. So here we go, 1, 0, 0, 0 instead of 0, 1, 1, 1, 1. So that's the first half of this. Now let's take a look at the second half. So for the second half, we need not A and not B. So here's not A. A was 0, 0, 1, 1, so not A is 1, 1, 0, 0. And here's not B. B was 0, 1, 0, 1, so not B is 1, 0, 1, 0. Now what is not A and not B? Well, it's just going to be this and up here. So the only time not A and not B are both true is up here, so it's going to be 1, 0, 0, 0. Now look at what we just showed. We just showed that not A or B is the same as not A and not B. So we proved DeMorgans Law. Here's an example of a Carno map, and we're going to write out a logic function. So we've got two inputs here, A and B, and an output Q. And we want to figure out what the logic here is. So the first thing we're going to do is put together our Carno map, sort of flip our truth table over. And what you see here is that in this case we had Q is true when A is 0 and B is 0. So here's A is 0 in this row and B is 0 in this column. So here's the 1 for that. And then Q is true when A is 0 and B is 1. So here's A is 0 and B is 1. So that's this one here. Now we go through and we circle the largest block we can. It's here. And what is this value? So this value here is just not A. So this row here is when A is 0. So since we circled the whole row, the answer here is not A. And so the equation for this is simply C equals not A. If you go back to our input here, it becomes pretty clear all of a sudden. You just take A and invert it, and you get the output. So it has nothing to do with what B is doing here. Here's a more complicated Carno map. So this Carno map has 3 inputs, so it's going to have 8 possible outputs. And this is how you write a Carno map with multiple inputs. So we've got C in, this first input down the side here, and A and B along the top. And if you look at this, I've written them in a special way. So A is false, B is false, then A is false, B is true, then A is true, B is true, and then A is true, B is false. So this isn't the usual way you count in binary, but what this means is it means only one bit changes between each one of these values. Here B changes from 0 to 1, here A changes from 0 to 1, and then here B changes from 1 to 0. That allows us to draw boxes and have only one thing change. So now let's go ahead and fill in. So we've filled in our Carno map here using the values that we had from our truth table, and now it's time to select the largest boxes we can. Now you might be tempted to think I could draw a box around all 3 of these, but you have to draw a box in powers of 2. So 1, 2, or 4 size boxes. So I can start out with this box here. Here's a power of 2 box. And what is this value? Well, this value is whenever Cn is true, that it's in the Cn is true row. And what are these 2 columns? What do they have in common? Well, they both have a 1 here and a 1 here for A. So this box right here is Cn is true and A is true. Let's draw another box. There's a box over here. What is this box? Well, this box doesn't have anything to do with Cn because it's true when Cn is 0 and 1, but it's when this column is true. And what is this column? Well, for this column, A is true and B is true. So this is A and B. And then finally, we have one more box here. This last box, well, this box is true when Cn is true, and it's true up here when B is true and B is true. So this is Cn and B. And you'll note that these boxes overlap. But that's fine because the final result is going to be the OR of all of them. So if they're all true, that's fine. You still get a true answer. So here's the logic for this truth table. It's Cn and B, or A and B, or Cn and A.